Hello, everyone. Today is January 14th, 2019. This is the first meeting for the Cluster API vSphere provider. This is a public meeting. Today, it appears that we have mostly VMware people, but let me get a link to the meeting notes here and then paste it in the Zoom chat. And then if you guys can, go ahead and add your attendee information, and if there are any topics that you guys want to talk about, please go ahead and add those to the agenda item. So far today, I don't really have any topics that I want to talk about. I think, Siddharth, you had some topics that you might want to talk about, so
sure.
Go ahead and add them.
Yeah, I'm actually just getting, yes, and thanks a lot, Locke. I'm just adding the link. 1 second. So, so I've created like one topic is, let me actually first put the link. 1 second.
Which group?
Okay. So I just put a link for a PR in the talk for those who wants to look at it. So the title for this particular PR essentially is to add support for injecting custom trusted certs onto the machines. So let me just give you a little background about like why I think, why this came in as a requirement that I thought. So one is, and oftentimes when we are doing Kubernetes clusters, in general, unless you are doing everything with public certs, with like certified certs, there are occasions where you want some custom like self-signed certs or not so trusted certs to be supported by a cluster or by various different services for that matter, or just plainly on the nodes. So what this particular patch set attempts to do is to add a new field called trusted certs, which is a list of base64 encoded certs, CA certs that can be then defined in the spec itself. And the resultant would be when the VM, or which is the worker node or the machine node, gets created, these certs will be injected to will be added to the machine's CA, like the trusted CA certs, so that any interaction with whatever that external service which might present this particular certificate that you want to do will not be flagged and will go through properly.
Okay, so Siddharth, where will these certs be saved? I mean, the first question is which configuration files are these certs going to be in?
So the way these certs, if you look at like the change sets, what we're doing is, so from the machine template, ultimately it lands into the CloudNet user data. So CloudNet has a defined way of specifying CA certs that somebody who's using CloudNet for basic things can define and can add any additional CA certs that they want to add. Yeah, so actually if you go to the files, and I can, if you scroll down to, there's a template.go file changes. Yeah, keep going.
Okay, here we are.
Even a little bit more further, a little bit more down. Yeah, right there. Yeah. So if you see here the line 269 to 276 that are in addition, where you have like the trusted cert. So that particular block is what is added to your. So this is the block which represents the CloudNet user data part of it, and it adds a new section for CA-certs. And again, and this is specifically how CloudNet documents any users to add any inject any new CA certs. Now on the system, if you were to run this, what will happen is under the, I think under HC SSL CS certificates, like I guess for Ubuntu that is probably the path, but I guess for different distros it could be different. But that is handled by CloudNet. But essentially, your default location where your system CA signed certs are there gets added to that. And this just gives you a nice way of saying, you know what, I want to support these additional certs, and could be used that way.
Okay.
Yeah, I mean,
By
so
the way,
yeah.
by the way, the certs are the root CA.
So these are just CA certs. So it could be a root CA cert. I mean, depending upon. So for example, as a use case, for instance, here in our system, for a different service, like for let's say if you're running an API, like just I'm not talking about in Kubernetes. I'm saying just in general. Let's say if you want to run some service which is doing some APIs, exposing some APIs, and you were to secure it with HTTPS, you would generally go and say generate a self-signed cert, or maybe generate a CA cert, self-signed CA cert, sign a certificate with that, and do that, go down that path, which is the standard way of dealing with when you have a self-signed certs. Now, in this case, what will happen is those CA certs that you generated, which are the self-signed ones, but at least it's valid in your ecosystem of your system, then you can inject those in the definition, and then all the machines that gets created, they by default now start validating these certs or trusting these certs implicitly.
So, Siddharth, is this a list of certs?
Yes, it is a list of certs. So if you look at, if you go to the very top, in the example, there is a template.example, I think, in the very top. Yeah. Yeah.
Okay, right here. Okay.
So this ZZZAA is nothing but like the base 64 encoded cert. So you can give one or more certs if you.
So I will tell you the one comment that I will add to PR will be to add some documentation. So we're going to probably start following the same approach the public cluster API adopted at the end of last year, which is that any PR that goes in that adds any new feature, we should add some documentation to it.
I mean, I did update the README, but I guess, yeah, I mean, do we
that's what I meant, yeah.
Yeah, I mean, I already updated the README file to basically reflect that change. However, it doesn't add any additional paragraph or, but verbatim essentially do it. Maybe we can do that as well. Yeah, I mean, we can definitely do that. I mean, that's not a problem. So one thing I do want to bring it up essentially in the discussion is I think on the actual issue that I opened corresponding to this PR, Craig Tracy, he responded, he posted a comment onto that where he had some suggestion, and I actually spoke to him one-on-one, like I think last week. One of the suggestions that he brought up was around, can we, for example, expose the entire Cloud Init template as a field so that the users can pretty much whatever they need out of Cloud Init, they should be able to use it without having to go via this route where the API definition comes into place, where you expose a particular field via the API, and then you. So I don't know. I mean, that was one of the suggestions. I kind of responded to that as well. I mean, in terms of there are pros and cons of that, but I don't know. Maybe
What's other pros and cons? I feel that's an option.
No. So I mean, I do like. So in general, I do like that idea because that gives you a lot of flexibility. So from the cons side, if I were to bring in one con, which is it gives you too much flexibility in some sense. For example, one of the difficulty that I see is if we have that entire Cloud Init data as a field, available as a opaque field that you can just put in some entire template in it, then how are we going to test, for instance? Because with Cloud Init, you can do a lot of things. You can do networking, you can do, pretty much a bazillion things in it. Now, it might become a challenge to say, how do we verify, for example, if the current system is working or not? Secondly, the other thing is, for today, the current implementation uses Cloud Init for injecting, for example, the scripts, using user data, and so on and so forth. Therefore, if you do expose the entire template as a field, what it would mean is we will either have to make a documentation saying that, okay, if you are trying to, let's say, inject a certain piece of data using user data section, that will be overridden by our script. Because, for example, the way the specific properties that we are using of Cloud Init template to inject the scripts and things like that, now we can't have the user also specifying the same thing to do something different. So then,
Well,
like, how do you do?
what we can do is that we say that this is a very advanced feature, expert level feature, and if you do that, then we skip our injection.
Well, but then, okay,
We basically let them shoot the stuff in the foot if they want.
I see. Well, but but I guess there's going to still be a challenge with that though, Locke. So for instance, one challenge that I see is today, for example, when we prepare our CloudNet user data, one of the things that we inject is we generate the kubeadm token from the master, and then we inject that token, and that's all coded in, right? Now, if somebody were to just put that template as an override altogether, as a blanket override, they will not have any way of getting that information, like that token, for instance, right? Which they need at the runtime, right at that moment.
Siddharth, is this for worker node or master node also, the CloudNet?
No, so this is like a general, like it could be for both. It doesn't have to. I mean, it's just general machine definition extension. So,
because yeah, one of the thing could be like we say, hey, this is how we can, if we can dump the CloudNet for the worker nodes, and someone wants to take and modify as per their need, we can just override. I think trying to merge, and that might make it a little bit more complex. Rather, give control to them and let them do whatever they want to do. But there is already a dumped version of all the information that they need, for example, the token and all those things.
Right. But the point is the token is time sensitive, right? I mean, token expires in like 10 minutes. Yeah. So you can't really, I mean, even if you give a dump to say, oh, here's the token, but the token is only going to be valid for the next 10 minutes. So right now what happens is the controller keeps track of the expiry time left on the token before injecting into the CloudNet user data. It ensures, for example, that you have at least, let's say, 5 minutes or 10 minutes still remaining for the validity of that token before it uses that into the system. Otherwise, it will actually go and create a new token and then use that for your machine.
I see.
So there is a bit part, doesn't say there's a small bit part of data which has to be a little bit more dynamically generated on the fly. For let's say if there was no requirement for a token, or if we deal with token in a different way, I mean, either ways, right? Then yes, we could make it, advanced feature, you go and use the CloudNet stuff to do whatever you want to do. I mean, so for example, just to give one more additional point on that line of thought is, let's say if we decide to change the way we inject the token today. So today we are injecting the token using user data, but we can potentially also inject the token using the VMX properties. That, using the VMware tools, somebody inside the guest can just request and fetch. So yeah, I mean, we can potentially depend upon a different mechanism, but that will be a little bit more change that we have to plan around.
Yeah, I mean, I was going to say something similar, like if we keep two different sources for CloudNet, there are multiple ways how CloudNet can read the data source. And if today Cluster API is using the ISO, there can be some other mechanism. Like, for example, in OpenStack, they use the metadata proxy. If you can separate what Cluster API is doing out of the box using, let's say, the VMX property, and for all the customization that one would want to do, they can go through the ISO route. It can be an option.
Right. I mean, I guess, yeah, I mean, it's just about kind of carving out that neat line to say, okay, what part of the functionality we do want the users to be able to completely override and take care of, and what parts of the information is something that the system as a cluster API system has to provide, and it can reliably get to it. I mean, so to the part of the CloudNet, interacting with VMX, we already use the module that was written by Andrew, which uses VMX as a source for the CloudNet data. So we can potentially be, I mean, we are using it as well. So yeah, I mean, one other addition thing just I want to briefly point out that, like, when I was talking to Craig, who commented, so one of the things he mentioned is he actually wrote a complete module in CloudNet specifically to mimic kubeadm, so that you can actually use like a YAML-based definition of your kubeadm to actually run through all these things. So his point was, if we go down that path, then we may be able to actually completely get rid of any sort of shell script that we have to run inside the host. Because if if everything is pre-installed, let's say kubeadm is there, kubectl is there, and all of the binary things are there, and it's just about running the right kubeadm command, we could actually leverage the additional module that he wrote for kubeadm interaction. And in that case, in that way, we can completely get rid of the shell scripts, for instance. But that's another idea that we can probably think about and maybe discuss more.
Yeah, I would like to read over Craig's comment, but I can't actually listen to you and read that at the same time. So I'm gonna after the meeting I'm gonna read over this. But it sounds like it does sound like it's a very narrow use case. So I kind of agree with you that maybe right now is not the time to spend any effort on supporting what he wants.
Yeah, I mean, I think I think what he was alluding to is that this is a common. I mean, he wanted to tackle this at a provider agnostic level, so not just for the vSphere, but essentially his point was today OpenStack, AWS, GCE. I think they all of these different providers, they all use Cloud Init in some shape or form to orchestrate stuff. So given that is the case, can there be something general that we can come up with, which can handle this? So it's a little bit more broader discussion, but I guess that was just the point that I thought we'll bring in here since he's not in this meeting right now.
Okay. Yeah, I understand the what he wants, but it doesn't actually, like you said, it's a broader topic and not specific to this issue. So maybe we would, in the next meeting, if he comes to the meeting, he can propose that again.
Yeah, I mean, maybe. Yeah, I mean, I'll ping him to maybe join our next meeting so that we can have a broader discussion.
Okay.
Yeah, I think that's kind of a long-term thing to think about it. But I agree. I think he brought up a good point.
Yeah. Okay, so let's go ahead and move on to the next topic. Hui, you have a topic and also another pull request, I see.
Yes, this is a send pull request to has a E2E to run the OVA build, and we had the PR open before the break, and after that I come back and work with Fabio. Realize there's some problem to run the OVA build in the Pro environments, because in Pro we are Debian best container, and this OVA build is kind of highly depends on their Photon environments. We initially thought we can make it run on other container environments, try to build the TDNF on the Debian, and turn out it's too much work. It's triggered a lot of other things we tried, and so the TDNF is the Debian package. It's their Photon package management. So then, so now I think I just discussed with Fabio, and we will try. So we will still need to have the Photon environments, but we will run in the Docker in a way that it's launched by a Debian container in Pro, then launch a Photon container and build. So I'm in the mode of doing this, and hopefully it's work out.
Okay.
So we one quick question. So I just looked at that pull request, and so you guys trying to build the TDNF into Ubuntu? I mean, why?
That's a work. Last week we tried and found out it's not feasible in this moment.
But I mean, may I ask, like, why? Like, what was the motivation of porting TDNF onto Debian? I mean, what was the...
Okay, so the background is to compile this OVA build, we need the environments. We need the tools, and those tools are basically Photon. Basically, if we open the Docker file, we install a bunch of tools. Those are based on the Photon tools, and we use the TDNF to install those tools. And to make it non-Photon dependable, then we have to install those same tools in other OS, in other container. So we try to make it work on the Debian, and then we found we need to install the TDNF itself. And TDNF is the binary VMware, basically the Photon team own this, and they only compile it on the Photon for Photon OS. So in order for us to run it, we have to compile by ourselves.
So this image that you're talking about, I mean, is this the container or the Docker file that you're talking about? Is this the Docker file that is used to build the OVA?
Yes. Let me share.
Okay, I'm going to go ahead and stop sharing, and you can share.
Sure. Give me a second. You guys can see me, see my screen, right?
Yeah.
Okay, so it's under build. So this is the installer. This is where how we build the OVA, and this is done by Fabio. The Docker file I'm talking about, we need this to build an OVA, these environments. You see all the tools it's need to install, and so the question is, how can we make it work on, if we can make it work on other operating system like Debian, then it's perfect. We don't need to use Photon. But
so is there like something stopping us from not using, so this image, I'm guessing that this Docker file, looking at it, it seems like you will just like generate it once, and it's more like a tool, like it's like a utility image that once you have generated, you just use over and over to build the OVA, right? I mean, I don't see anything in the Docker command here to say like copy the current directory or copy the source code or the current set of source code, anything like that.
You're right, but the build shell script has the hard code call TDNF to do certain things. For example, I think it's, let me see, I think it's here. So it has some,
okay.
I'll do a quick search. So it should show.
So Darth, what is your thinking? I mean, a lot of this work is based off of the stuff that we did.
Well, I mean, so what I was thinking is, I mean, so the Docker file that we was referring to, right? To me, it seems like it's a one-time tool that we generate, container image that we generate once, and then we use it every time to build the OVA, right? Now, given that, I mean, is there any restriction? What I was going to lead to is like, is there any restriction on the PRAO environment that we cannot use? Let's say if we were to build this image, publish it to Docker Hub, for example, is there a reason why we cannot pull this image on the PRAO environment to do the same job?
Well, I think go ahead, Hui, if you want to answer. Go ahead.
You go ahead.
From what I understand, PRAO uses a Debian container for running. So if Hui, you correct me if I'm wrong, but what Hui is talking about is we're going to run a Photon container within the Prow Debian container. So it's Docker in Docker.
So okay, so even if you go Docker in Docker, right? So I mean, so I guess seems like in the Prow environment, the entry point for us as a repository is when your job runs, you are inside a Debian-based container, right? Mm-hmm. And now you have to, whatever you want to run, you have to basically make use of that environment, and anything that you want to build is on that, right?
Yes.
And first of all, I mean, do we have an option of Docker? Do we have an option of running Docker inside the Debian environment, like a Docker in Docker kind of a scenario? I don't know.
Apparently,
we do. So that's a route that I'm going now. So this is what you're suggesting. What I'm doing.
Okay. All right. So I mean, if you have Docker in Docker, then then essentially we don't have to change any of the Docker file, port any of the packages, right? We can just say in the Docker in Docker case, pull the image, the Photon OS-based image, which you already have all the tools and you're building everything, right? And then just go with it.
But we still have to change. Anyway, there's some detail. I'll update the diff, but we do have to change the current Docker file because the current Docker file only includes the general tools, does not include all the installer code in that folder. What Fabio initially did is when launch this Photon container, it's passing the current context, which is the host context, and basically the container has a host context, so it can get all the code and finish the build. But in the CI environment, we don't have. We run in the container Docker in Docker. So that's why I modified the Docker file now to have to package all the installer code into the container. Okay. But that's a detail. But the route I'm choosing is run this Photon container in Docker in Docker, and yeah, I'll update the diff there.
Okay. So so we're going to build on Prow.
Yeah, so we have to build in runtime, build this container again in runtime, and then launch it.
So we're building the OVA on Prow, the Prow environment on Google.
Yeah.
Okay.
Yes.
Well, free CPU and storage.
Yeah, that's true.
Okay, so I guess the last topic I want to bring up is KubeCon Europe submission. It's ongoing right now. The last day is this Friday. So, and I think there's the one for Asia is also very close to this date. When before the holiday break, I looked and they were like back to back. So if anybody wants to do any submission related to Cluster API and would like to collaborate on one, go ahead and ping me. I do actually have 2 ideas for submissions, and I'm going to write up both abstract. They're kind of tangentially associated with Cluster API. Cluster API is going to be used for it, but it's going to be they're going to be very different from the topic I presented at KubeCon North America. So for Siddharth and your team, if you guys want to submit one for Europe and Asia. Now is the time to be thinking about that. You know, the one for North America, the big one, isn't. I don't think that even starts until May, the submission or something. It's around middle of the year. Okay. I think that is all the topic that we have. If anybody else wants to bring up any other topic, go ahead and do so now. If not, then we can go ahead and end the meeting for this week.
We have the Dewal join the call. Maybe he has some question or.
Dewal, do you have any topics you want to bring up or any ideas for KubeCon that you want to discuss here, or we can end the meeting?
Oh, no, I don't have any questions. Thanks.
Okay.
Thanks. Look.
Thanks, guys. I guess we will go ahead and end the meeting. Thanks for joining. This concludes the first meeting of the year.
Happy New Year, guys. Thanks.
Thanks, guys. Happy New Year.
Thanks.
Bye.
Bye.